let's start the new chapter after completion of the solutions. The new chapter let us start today, that is electrochemistry. Let's start the electrochemistry. So in this electrochemistry, mainly the total chapter I am dividing into 4 topics, 4 lessons let us take. So all these 1, 2, 3, 4, one by one I'll tell you. Number 1, first topic means first lesson of this chapter is conductance of electrolytic solutions. The first part, this is, we can take it as main heading also. Number 1, conductance of electrolytic solutions. Like that, second part, third part, fourth part also there. Then chapter will be over. The first part let us discuss now. Conductance of electrolytic solutions. See, what are electrolytes, what are non-electrolytes? These are the basic points in this topic now. Electrolytes means what? The molten solutions or aqueous solutions through which if electricity passes, then they are called electrolytes. If electricity is not passed, then we can say there are non-electrolytes. In this topic, we have to take the electrolytes, means through ions or through aqueous solutions or molten state, current has to pass. Then they are called electrolytic solutions. And some substances are also there, conductors. These are all electrolytic conductors. Electronic conductors also there. Before discussing this topic, the basic point I'll tell you. The basic point is conductors. Conductors means the substances through which when current is passes, then they are called conductors. This is a basic point. The conductors are of 2 types now. Conductors are of 2 types, that is number 1, electrolytic conductors. Number 2, electronic conductors. Electrolytic conductors, electronic conductors. We don't want this, we want this one only. Electronic conductors means our current wires. These are all present in the solid state. Copper wire, aluminum wire, these are all metals, solid state. In these metals we have the ions also, electrons also. Metal atoms are able to lose the electrons. Through these electrons, current is passing always. Current wires. In copper wire, through the copper wire we have copper electrons lose karega. Through these electrons, mobility of these electrons, current is passing. So these are all called electronic conductors, in which electrons are used to pass the electric current. Now there are electrolytic conductors. Electrolytic conductors means substances which are in the molten state or in the aqueous state, through which current is passing through the ions of these substances. Suppose NaCl, KCl, either in the molten state or in the aqueous state, you will get the positive ion and negative ion, K plus Cl minus, Na plus Cl minus. So through these ions, current is passing. So these are all called electrolytic conductors. So we want these electrolytic conductors in this chapter. So electronic conductors, electrolytic conductors. Here through the electrons current passing. Here through the ions, here the current is passing. So these are all called as conductors. So let us discuss the conductance of electrolytic solutions. Conductors are different. Now conductance is different. Here some new words are the new words will come in this topic. You have to clearly understand all this. I will tell you all these words differences. Conductors, conductance, both are difference are there. See, first topic is conductance of electrolytic solutions. So let us start the first topic of all this. Before discussing the first topic of the conductance of electrolytic conductors is number one, Ohm's law. Let's start with the Ohm's law. Ohm's law, it comes in the physics also. So I am taking one conductor. Conductor I am taking. Conductor means current is passing through this. Its area of cross section I am taking A. Area of cross section is A. Length of this conductor is L area. Length is L. So if you apply the Ohm's law to this, Ohm's law explains that according to Ohm's law definition देखिए, the resistance of this conductor, resistance R, symbol resistance, the resistance of this conductor is directly proportional to length of this conductor and inversely proportional to area of this cross section. The resistance is directly proportional to length of the conductor and inversely proportional to area of cross section. When length is more, resistance also more होगा. When resistance more, current flowing slow downs. If area of cross section is more, resistance less. Means जितना ज़्यादा area होगा, current flow ज़्यादा होगा. Means resistance कम होगा. When resistance less, current flow is more. When resistance more, current flow is less. Resistance more when length is more. Resistance more when area of cross section is less. This is Ohm's law. Let us remove the proportionality here. Here I am saying the words definitions. देखिए, here R means resistance, L means length of the conductor, A means area of cross section. Now I am removing this proportionality here. R equal to, if you remove the proportionality, you need to keep some constant, that is rho. Rho is the constant. So rho into L by A. What is rho here? See? Since, see here one equation. This is equation number 1. Since here rho equal to specific resistance. Specific resistance, or we can say it is resistivity. Specific resistance or resistivity is called as rho. So rho is the specific resistance or resistivity. R is the resistance, rho is the resistivity. That is actually the definition. So this is over. So after this Ohm's law is over, let us use these terms in further derivations also. If Ohm's law is completed, now I will give one more definition also. That is, see, conductance. Conductance symbol is G. I am taking the symbol for conductance is G. How do you define this now? The conductance G can be defined as, it is the reciprocal of the resistance. The reciprocal of the resistance is known as conductance. Means when resistance is less, conductance will be more. Conductance means the ability of the flowing current only. So it will be more. It will be more when resistance is less. Exactly how do you define the resistance is? The conductance is the reciprocal of the resistance. This is I am taking as equation number 2. I am taking this is as equation number 2. Okay, we will use this equations later, but before that, what is the unit of the resistance? Resistance का unit we know ohm. Resistance unit is ohm, and the conductance unit will be what? The unit of resistance means ohm, 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 or the symbol is ohm, or the symbol is like this. This is the unit of resistance, ohm, or the symbol is like this. Now what will be the unit of G? The unit of G is 1 by rho, means 1 by resistance. 1 by resistance means 1 by ohm. 1 by ohm means what is its unit now? The unit of G will be ohm inverse, or look at the symbol, ohm inverse, or we can say it is mho also, MHO. Ohm ka reverse, MHO, mho. Ohm inverse, ohm ka reverse, MHO also. Or we can write S. S means Siemen. Siemen also we can write. The ohm inverse ko we can write S also, Siemen. These are all the units of the G. Means the unit of conductance, ohm inverse, this is a symbol, or mho, or Siemen also. Siemen is also the unit of G, means conductance. So ये हो गया conductance. Next one, I am substituting R value there. Substituting 1 into what we are getting, because G equal to 1 by R means R means rho into L by A. I am substituting this rho into L by A in the place of R. So nothing but substituting 1 into 2. See what we are getting. Substituting 1 in 2. See what we are getting. Z equal to 1 by R means what? Rho into L by A. So 1 by rho into L by A. So from this, see what I am doing. 1 by rho I am writing. So from this, see 1 by rho only what happens? G into L by A. 1 by rho equal to G into L by A. Here rho is the resistivity. 1 by rho is again constant. Rho is the resistivity, it's a constant value. 1 by rho again constant will come. So what will you get now? Again constant will come. That's why I am writing 1 by rho as K. K means what I will tell you. 1 by rho means K equal to G into L by A. L is constant, again A also constant. For a particular cell is taken, its length is same hoga, area of cross section also fixed hoga. So means the ratio of these two also we can take it as a constant. That is I am taking as this G star. So K equal to G, G star is another relation. This is equation number 3 I am writing. Since K means what? The K means 1 by rho. This is called conductivity, or we can write it as specific conductance. Don't be confused in these words. We have got resistance, resistivity, conductance, conductivity. See all these 4 terms. Resistance means capital R, resistivity means rho, conductance means G, conductivity means K. The conductivity is also called as specific conductance. Conductivity is also called as specific conductance. Resistance is also called as specific resistance. Conductivity nothing but specific conductance. Resistivity nothing but specific resistance. All these 4 words and abbreviations you have to understand. Okay, first one क्या है? Resistance R, resistivity rho, conductance G, conductivity means what? Conductivity K. So like it we got it. This K we can also say that this K का another name है कप्पा बोलते हैं इसको, कप्पा KAPPA. But don't use the word always kappa. I mean just use K. K means kappa. This K means 1 by rho. 1 by rho means nothing but specific conductance. How do you define this conductivity now? How do you define conductivity or specific conductance? You will get one definition. It is the reciprocal of the resistivity. The conductivity means the reciprocal of the resistivity is known as conductivity. You have one definition again, that is for K. The K ka another definition also there, that is I will tell you. K has another definition also there, that is I will tell you later. First the K means conductivity. It can be defined as, all these definitions you have to know, you have to write also. The conductivity K can be defined as the reciprocal of the resistivity is known as conductivity. Next one. And here K means 1 by rho, we got it. What is G star? Here in the place of the L by A, I got it as G star. So it means what? G star means L by A, means the ratio of length and area of cross section is G star. This is, we can say, cell constant. Another statement comes cell constant. The G star means the ratio of the length of the conductor and area of cross section. It is called cell constant. So the K means conductance and cell constant. Product is conductivity. These are all the statements. So this is, I can write it as equation number 4. All these you have to learn. So we got all these definitions, all these formulas. Okay, let us derive the unit of the K and unit of G star. Tell me the unit of K, unit of G star, what happens? See, you have to know all these terms, units. Tell me, K का unit क्या है? G unit means what? G is 1 by rho, means ohm inverse. G means ohm inverse. G star means L by A. L by A. L is centimeter ले लिया तो A centimeter square. So here centimeter by centimeter square. If you cancel it, so you will get ohm inverse centimeter inverse. अगर आप लोग सेंटीमीटर ले लिया तो ऐसा होगा, अगर आप लोग मीटर ले लिया तो मीटर बाई मीटर स्क्वायर, मीन्स ओम इनवर्स मीटर इनवर्स आ जाएगा. सेम सिमिलरली, और इट कैन बी ओम इनवर्स मीटर इनवर्स आल्सो इफ यू टेक दिस इज इन मीटर्स. ये ओम इनवर्स प्लेस में सीमन आल्सो वी कैन राइट. You can get like this, Siemens centimeter inverse or Siemens meter inverse also we can write. देखो ये ohm inverse place में Siemens also we can write. I already told you. So the unit of this one is ohm inverse centimeter inverse, ohm inverse meter inverse, or Siemens centimeter inverse or Siemens meter inverse also. All these are, we can write it as a unit for unit of K. Now the unit of G star क्या होगा? Unit of G star, if you take L is as centimeter, if you take this is as centimeter square, now the unit is what? Centimeter inverse. The unit is centimeter inverse. अगर आप लोग मीटर स्क्वायर ले लिया तो मीटर इनवर्स आ जाएगा. So the G star unit will be centimeter inverse or meter inverse में we can take. So these are all the formulas. ये formula based questions are there. You have to understand all these 4 terms. Number 1, once again I am saying, these are all confusion आने वाला terms है, but no need to confusion that. See, once again I'm explaining. Number one is number one क्या है? Resistance, R resistance, resistivity. Conductance, conductivity. Resistance R, resistivity rho, conductance G, conductivity K. In addition to these four, one more came G star. G star means cell constant also. All these four terms ka you will get the formulas also. You have the formulas also. These formulas you can get it now. Already formulas all. Based on these formulas, we have the numericals also. These numericals along with the units also I told you. Now I'll tell you one more statement is there for the conductivity. That is, I'll tell you now. The conductivity K means K ka another definition. Actually K is 1 by rho, means the reciprocal of the resistivity is known as conductivity. This is one definition. Another definition also there for the K. You see this. K means we know G star. K means G star. Nothing but K equal to G into G star means L by A. G into L by A. L is the length of the tube, A is the area of cross section. So another definition I am explaining now. See how it is. Suppose if the L is 1 centimeter. If I am taking as 1 centimeter, A is I am taking as 1 centimeter square. Means the conductor has 1 centimeter length and the area of cross section also 1 centimeter square. Then what happens this formula? K equal to G. So how do you define this K? The K can also means the conductivity. The conductivity can also be defined as the conductance of a solution. The conductance of a solution of 1 centimeter length and 1 centimeter square area of cross section. Means the conductance of a solution of 1 centimeter length of the conductor and 1 centimeter square area of cross section. That is called K, conductivity. K equal to G. When K equal to G, it has L1, A1. What is L? Length of the conductor. A means area of cross section. It means to understand very clearly, I will give diagram also. See, this is electrolytic conductor. Electrolytic conductor means one cathode, one anode we should take. Cathode and anode should be separated by 1 centimeter length. Cathode and anode separated by 1 centimeter length. This is one electrolyte area. This is one electrolyte. If I am taking electrolyte on ionizes, ions are forming. Through these ions, current is passing. That is called conductance. The conductance of all ions present in the solution of 1 centimeter apart of the electrodes having 1 centimeter square area of cross section. Means these electrodes area of cross section 1 centimeter square hona chahiye, and electrodes should be apart, means separated by 1 centimeter. Then whatever the ions are there, through all these ions, whatever the conductance is coming, that is called K hoga. Another definition. So how do you define again? The conductance of a solution of 1 centimeter apart of electrodes of 1 centimeter square area of cross section is known as conductivity also. This conductivity increases when conductance increases. Conductivity increases when conductance increases, means number of moles of ions increases, the conductance or the conductivity also increases. If number of moles of ions increases means G increases. As G increases, K also increases. This is actually what happens. The K. Suppose tell me if it is on dilution. See what happens. If it is on dilution, suppose here the conductivity K depends on the dilution also. The conductivity K depends on dilution also, but this dilution and how it depends on K separately I will tell you. Before that, the K definition is over. After that, some other definitions also there. Let us finish those definitions first. After that, I will give remaining factors. How it depends upon their dilutions, I will tell you. So this is K. K is over. Now, so here the conductivities are totally 3 types of conductivities are there. This is number 1 conductivity, and another conductivity also there. See, the another conductivity, first conductivity K is over. Number 2 is molar conductivity. Molar conductivity also there. Molar conductivity. It is just the first one is K is over. K is just conductivity. Now you see molar conductivity. Its symbol is lambda m. This symbol is also called as lambda. Like this way we can write. See, this is also called as lambda. Not only this, it is also called as lambda. It is also called as lambda. In this case, let us use this symbol. So lambda m for molar. So molar conductivity. How do you define this molar conductivity? Definitions देने के पहले उसका formulas दे देंगे, so that definitions you can understand very easily. देखो definitions how to write the formulas. देखो lambda m is equal to K by m लिखेंगे first formula में. Lambda m equal to K by m. So how do you write this one? For this one concept I will tell you. See, molarity means what? Number of moles per volume. Here मैंने m ले लिया. Here K means conductivity, we know. Here m ले लिया. M means molarity. Molarity means number of moles per volume. Suppose tell me if n equal to 1 mole. If n equal to 1 mole, then molarity क्या होगा? 1 by V होगा. Molarity is 1 by V होगा. So tell me from this V equal to what? 1 by m होगा. V equal to 1 by m. So what I am doing is, in the place of this 1 by m, I am writing V. See what we are getting? Lambda m equal to K into V आ जाएगा. K into V. But V means what? Length into area of cross section. V means length into area of cross section. This is another formula. Right? V equal to length into area of cross section. See, but V equal to L into A. But what I am taking is L 1 centimeter ले लेंगे. L is 1 centimeter. So then V equal to A होगा. V equal to A if L equal to 1 centimeter. This is one part. If L equal to मैंने 1 centimeter ले लिया तो V equal to A होगा. Then what about this formula now? This formula is lambda m equal to K into A होगा. K into A. See, how do you define this molar conductivity now? ये molar conductivity definition समझ में आने के लिए, see, मैंने ये same ले रहा हूँ. इधर electrodes ले रहा हूँ. Electrodes माने cathode, anode ले रहा हूँ. Cathode, anode. These two are separated by 1 centimeter length. The two electrodes are separated by 1 centimeter length, and the area of cross section should be taken as more. A large area of cross section ले लेंगे. इसलिए ये I am not taking as 1 centimeter square. ये area of cross section मैंने ज़्यादा ले लिया. And here electrolyte I am taking. Electrolyte. How much electrolyte I am have to take? 1 mole. Here 1 mole of the electrolyte should be taken, and its volume should be V centimeter cube ले लो. Volume is V centimeter cube, means 1 mole per V centimeter cube ले लो. अब ये मोलारिटी आ जाएगा, मोलारिटी आ जाएगा. So the conditions we need to take like this, means 1 mole of the electrolyte presenting V centimeter cube of volume, and in which electrodes are separated by 1 centimeter, and these electrodes having area of cross section, a large area of cross section is there. In this case, whatever the ions are forming from the 1 mole of the electrolyte, through all these ions, whatever the conductivity comes, through all these ions of 1 mole of electrolyte of V centimeter cube of volume, in which 1 centimeter cube distance separated by the electrodes, whatever the conductivity comes, that is called molar conductivity. Molar, 1 mole should be taken. Simply मैं क्या बोल रहा हूँ कि 1 mole of the electrolyte ले लिया तो in these 1 mole of electrolytes, whatever the ions are forming, through all these ions कितना conductivity आता है, that is called molar conductivity. This is called molar conductivity. Here A means area of cross section also should be considered there, because the electrodes having a large area of cross section is there. This is also you need to consider. Like this way we can define it. Means the conductivity of all the ions produced from 1 mole of the electrolyte of 1 centimeter cube, 1 centimeter length separated the electrodes having V centimeter cube volume. In this, whatever the conductivity comes, that is called lambda m, molar conductivity. Simply K into A, but see A V हो जाएगा. A V कब होगा? Because L into A, L is 1 centimeter. So L into A is V. So from this we got this. From this we got this. So from this we can get like this, or from this we can get like this also. इसलिए this is main formula we need to take. Lambda m equal to K into M. So M is here molarity. Molarity means number of moles per volume. See, once again this formula how it is coming. Molarity is number of moles per volume, We have considered here 1 mole of the electrolyte. Therefore, M equal to 1 by V we have taken. But V we wanted. V equal to 1 by M. So, V is 1 by M. So, we have taken this formula. So, in the place of this 1 by M, I have taken as V. So, K into V as I get. So, but V means L into A. But here L I have taken 1 centimeter. Therefore, V equal to A comes. V equal to A means lambda M equal to K into A हो जाएगा. So, like that we got it this formula for lambda M. But main formula is this. So, lambda M equal to K into M. Here, definition वजह से we can define like this. Means the molar conductivity can be defined as it is the conductivity of a solution in which conductivity of all the ions produced from 1 mole of the electrolyte of V centimeter cube volume, in which the electrodes are separated by 1 centimeter cube, which are having a large area of cross section. That is called molar conductivity. थोड़ा length ज़्यादा है. So, but the definition is like this. But this is a main formula. Based on this formula, we have the numericals. So, let us write now the units of this lambda m again. This lambda m also changes with dilution. Dilution वजह से change होगा. Means lambda m means molar conductivity. K means conductivity. Lambda m is molar conductivity. K conductivity. Lambda m is molar conductivity. So both are changes with the dilution or with the concentration. How it is, I'll tell you. Here molarity means concentration. Increase होने से lambda m decrease होगा. ये कैसे है क्या है मैंने नेक्स्ट क्लास में बताएंगे. बट बिफोर दैट ये लैम्डा एम का यूनिट्स लिखेंगे. यूनिट्स सपोज टेल मी इफ के इज इन सीमन पर मीटर ऐसे सिस्टम में के यूनिट आई ऑलरेडी टोल्ड यू. इफ के इज इन सीमन पर मीटर एंड लैम्डा इज इन मोल पर मीटर क्यूब. लैम्डा इज इन मोल पर मीटर क्यूब. क्या होगा ये सीमन पर मीटर ये मोल पर मीटर क्यूब. सो अब ये उल्टा हो जाएगा. पर मीटर मीटर क्यूब कैंसिल होगा तो मीटर स्क्वायर मिलेगा. देन द यूनिट ऑफ लैम्डा एम इज क्या होगा सीमन मिलेगा. सीमन मीटर स्क्वायर पर मोल मिलेगा. सीमन मीटर स्क्वायर पर मोल. This is lambda m सीमन मीटर स्क्वायर पर मोल मिलेगा if you take all these in these units. Suppose from this you can get another formula also. See, or I will give another formula also from this. So the lambda m equal to C K into 1000 by m also I am giving. So this is I think equation number 4 होगा. This is equation number 5 होगा from the beginning. Today whatever I discussed. This is one formula. This formula we have to use when K is in Siemens per meter, M is in mole per meter cube. If the values are in these units, this is the unit of lambda m comes. Another formula also there. Another formula K into 1000 by m. This comes from this only. How? A mole per meter cube I am converting into mole per liter. Mole per liter में convert किया बस. 1 meter cube means 1000 liters no. ये देखो mole per meter cube. But 1 meter cube means 1000 liters होगा. ये 1000 ऊपर गया बस. That is only simple. Here what I am taking is here mole. This is mole per meter cube. But per meter cube को I am converting. Here per meter cube को I am converting liters. How? 1 meter cube means 1000 liters. So here mole per meter cube को 1 meter cube प्लेस में 1000 लीटर्स लिख दिया तो ये 1000 ऊपर जाएगा. ऊपर गया इधर अभी मोल पर लीटर में मिलेगा. सो दैट इज व्हाई दिस फार्मूला कम्स अगेन. जस्ट यूनिट्स चेंजिंग. दैट्स ऑल. in this case अगर if this formula if you want to use K should be Siemens per centimeter. K should be Siemens per centimeter and M should be mole per liter. We have to use this one. K should be Siemens per centimeter because when we are using the liters means K should be Siemens per centimeter ही लेना पड़ता है. CGS unit it is. So mole per liter लेना है. If you use these units, this is the formula. Again you see liter means 1000 centimeter cube. Here again centimeter cube में आंसर आ जाएगा. इधर Siemens per centimeter, इधर centimeter cube आ जाएगा. So if you simplify this, ये centimeter cube ऊपर जाएगा, centimeter square मिलेगा. Then the unit of lambda m आ जाएगा Siemens centimeter square per mole आ जाएगा. If you use this formula, Siemens centimeter square per mole आ जाएगा. How it is? How centimeter square per mole is coming in this? Because I am converting again liters to centimeter cube. ये centimeter square है. देखो ये centimeters ये इधर क्या आ जाएगा Siemens per centimeter. इधर सेंटीमीटर क्यूब आ गया, ये सेंटीमीटर क्यूब ऊपर जाएगा, सो सेंटीमीटर स्क्वायर ही मिलेगा. That's all. Siemens centimeter square per mole is the unit of lambda m. Before I told you equation number 4 का Siemens meter square per mole. There is a relation between these two also. 1 Siemens meter square per mole equal to how many Siemens centimeter square per mole? These two are the units of lambda m. ये यूनिट होगा when k is in सीमन पर मीटर, m is in मोल पर मीटर क्यूब. ये यूनिट होगा when k is in सीमन पर सेंटीमीटर, m is in मोल पर लीटर. लीटर को अगेन सेंटीमीटर क्यूब में कन्वर्ट किया, ये सेंटीमीटर क्यूब सेंटीमीटर पावर -1 सेंटीमीटर स्क्वायर आ जाएगा. इफ यू इक्वेट देम, सो व्हाट विल बी देन 1 सीमन मीटर स्क्वायर पर मोल इक्वल टू हाउ मनी सीमन मीटर स्क्वायर पर मोल. जस्ट मीटर स्क्वायर को सेंटीमीटर स्क्वायर में कन्वर्ट किया है, बस. कितना आ जाएगा? मीटर स्क्वायर को मीटर इंटू मीटर लिखो, वो उसको सेंटीमीटर में कन्वर्ट करो. 1 मीटर मीन्स 100 सेंटीमीटर, अनदर मीटर मीन्स अनदर 100 सेंटीमीटर. 100 इंटू 100 कितना आ रहा है? 10 पावर 4. So 1 Siemens meter square per mole equal to 10 power 4 into Siemens centimeter square per mole होगा. So these are all the conversions and formulas of all these. Conversions and formulas of all this. So up to this we have a numericals. But before that I have to tell one point that how conductivity and molar conductivity change with concentration. This is tomorrow's topic. But before that, just like molar conductivity formulas, equivalent conductivity is also there. molar conductivity में molarities आ गया. अभी नंबर 3rd conductivity देखो, equivalent conductivity. इसका सिंबल है लैम्डा ई क्यू. इक्विवेलेंट कंडक्टिविटी सिंबल है लैम्डा ई क्यू. दिस इज इजी, बट मोलार कंडक्टिविटी जैसा ही होगा. मोलार कंडक्टिविटी में वी गॉट द फर्स्ट फार्मूला लैम्डा एम इक्वल टू के बाई एम. In this case, the equivalent conductivity first formula आएगा K by normality. That's all. Molarity place में normality आएगा because there molar conductivity, here equivalent conductivity. Equivalence will come in normality concept. That's why मैंने इधर normality ले लिया. This is first formula. Second formula of molar conductivity क्या है? Lambda m equal to K into 1000 by molarity आ गई ना. Similarly here also lambda EQ equal to K into 1000 by normality आ जाएगी. Units are changes, that's all. इधर K क्या है? Siemens per meter. M means moles per meter cube. So इधर क्या है? K is here also Siemens per meter. Here N means number of gram equivalents per meter cube. Simple. Number of gram equivalents per meter cube. इधर K क्या है? Siemens per centimeter. Here mole per liter. Here Siemens per centimeter. Here gram equivalent per liter. That's all. Same, simple only, but units are changes. Now I will tell you, if you use this formula, what is the unit of lambda EQ? In this case, the first one, lambda EQ का unit क्या होगा? Siemens. Here per meter, इधर नीचे per meter cube. ऊपर गया तो meter square मिलेगा. Meter square. ये तो equivalent है, so that's it. Equivalent per -1 means per equivalent, because here per means divide by n is there, no? Per equivalent. So this is the unit of this formula now. Unit of this formula. Now unit of lambda EQ, in this case क्या होगा? So the lambda EQ unit is A Siemens per centimeter. Here equivalents per liter. वो लीटर को अगेन सेंटीमीटर क्यूब में कन्वर्ट करो, ऊपर जाएगा. So you will get Siemens centimeter square equivalent power minus 1 means per equivalent. Here also same, मोल्स प्लेस में इक्विवेलेंट आ गया बस. सिमिलरली मोलारिटी प्लेस में नॉर्मालिटी आ गया बस. दैट इज अ चेंज, दैट्स ऑल. सो हियर आल्सो सेम 1 मीटर स्क्वायर, 1 देखो 1 सीमन मीटर स्क्वायर पर इक्विवेलेंट इज इक्वल टू 10 पावर 4 ऑफ सीमन centimeter square per equivalent. This is one statement. 1 Siemens meter square per equivalent is equal to 10 power 4 Siemens centimeter square per equivalent. This is the relation. Right? So molar conductivity, equivalent conductivity, conductivity. So K, lambda M, lambda EQ. These three relations we completed. Let us discuss about the relation between these two now. Means see, the relation between lambda M and lambda EQ derive करेंगे. Lambda M and lambda EQ. So we have a formula. First formula use करो. Lambda M equal to K by M, and we know lambda EQ is equal to K by N. So दोनों में equal करो. K is common there. So what will we get? So lambda M into molarity is equal to lambda EQ into normality. This is just similar to molarity normality relation मैंने बोला था ना, वही है. So from this we know one thing, that lambda M is equal to, ये नीचे लेके आइए. सो क्या है, N by M इंटू लैम्डा EQ होगा. ये M नीचे लेके आइए. ये N by M प्लेस में क्या लिख सकते हैं हम लोग? Therefore lambda M is equal to N factor into lambda EQ. What is N factor? Because since we know no N equal to Nm, normality equal to Nm we know no. So from this tell me, N by M means we can write N factor. That is I have written there. So this is the relation between molar conductivity and equivalent conductivity. Molar conductivity is equal to N factor of equivalent conductivity. I already told you in the solution topic, solution chapter में, how to find out this N factor. N factor for acids, bases, salts, oxidizing agents and reducing agents. For all these, how to find out this N factor, I already told you. These are all formulas. Once again, repeat करके ये video देखिए. If any topic is not understanding, ask me. So tomorrow I will tell you ये conductivities, how it is depends upon the concentrations and dilutions. Tomorrow next class में I will give is extension video. That's all today. Thank you.